Okay, so in this video we will discuss the question number 5. In this question number 5, we have to find out the dissimilarities between the student feedbacks, which are described by the nominal attribute, asymmetric binary attribute, and so on. So basically, these are the different kind of features of single data. So we have to find out how you can use these features to find the dissimilarities between student feedbacks. So the first one is the nominal attribute. So in the question they have given us that it could be the department and electives chosen. So if we take example of it, so let's just say we take example of as a department. So department could be any. Let's just say it is computer science. Okay, let's just say it is computer science or electronic, right? Let's just keep only two, right? So let's just say if a student X is in CS and student Y is in ECE, and again a student Z is in CS. So what we do in this in this kind of data, in this kind of a feature, is that we find out the dissimilarities, right? So if we create a function in which we assign the values, right? So 0 for x equals to y and 1 for x not equals to y. Here x and y are not student, here they are the features. So if two students feature matches, the dissimilarity score will be 0. And if two features doesn't match, their dissimilarity will be 1. To get to the conclusion, to compute the dissimilarity between the student feedback for this feature, there is a formula in which we first calculate the dissimilarity 0, 1 for all the features which are like this inside the student feedback dataset, and then we just put those values, and on the numerator we put the number of dissimilarities where the x is not equal to y. Where are how many values are that, and below that the total number of attributes, right? So this is one of the way to handle the dissimilarity thing in the student feedback if you get this kind of features, right? The next they talk about is the question the B, which is asymmetric binary attribute. So in this the answer is in simply two words, yes or no. So basically it's a binary thing, right? Either you get 0 or either you get 1, either you get yes, either you get no. So there in the question they have given us an example of if they have attended the workshop or not. So if yes, they have attended, if no, they have not. So to find the things for this type of features of a dataset, we usually use Jaccard dissimilarity formula. Jaccard dissimilarity formula, right? So what it says is that first count yes, right? So here it's workshop attendance. Either it's a yes or either it's a no. So what Jaccard dissimilarity says is that always think about yes, right? Never ever consider the no data, because it's not of that much use, right? So what it says is that let me first write its formula, which is m01 plus m10 m11 plus m01 plus m10. So what this formula says, here the 0 and 1 are no and yes, right? So what it says is that in the numerator, take the number of datas in which the one student says no and other says yes, or vice versa, and add those data. And in the denominator, take all the data. So in this involves the yes yes, no yes, and yes no. You can see we are not taking the no data, or if we write in terms of that, M00, because Jaccard dissimilarity says this is useless data. It will not affect the final outcome. So it's better to not take that data. So in the asymmetric binary attributes, we usually follow the Jaccard dissimilarity, in which we always focus on the yes part of, or a positive part of that attribute, right? And the formula goes along that. So this is the way of finding any dissimilarities or any conclusion for that data set if you encounter these kind of attributes. The next is the Minkowski distance, the next is the numeric attributes. So numeric means they can range from certain level, like the CGPA from 1 to 10, attendance from 1 to 100, right, or 0 to 100. So there are tons and tons of ways to solve it, right? So these are basically the values data, means they are numeric. Most commonly they are numeric, and they have a range. So to always get some valuable insights, if you have a range data, you always find out the distance. Always, I should say, always use the distance things, right? So at first, if I say, in this you can use multiple things, which is Euclidean distance. The another one is Manhattan distance. Another one could be the Chebyshev distance. These are all the ways by which you can get the insights from these kind of attributes, right? So in Euclidean distance, you basically subtract each and every features of that data and just root it by whole squaring it and getting a root of it. In Manhattan, you just take the absolute of xi minus yi and summation it, right? In the Chebyshevs, you could you always take the maximum value which you get during the difference, right? So these are some of the ways by which you can get the insights of this data and these kind of attributes, right? The next thing which we need to find is the term frequency vectors, right? So it's basically keywords in an open text feedback. So this is data is kind of non-predictive, right? It doesn't have a range. It doesn't have like binary values. It's totally based on, like, if a user just type in simply, let's just say this teacher explains good. And this is the input of one kid, and if another kid comes, he could type he explains good. So what this kind of attributes from what we can extract from these kind of attributes is that we can find out some common keywords from these attributes. For here we have explains good, explains good. So these kind of things can be get through the cosine dissimilarity. Right. So what is basically, it is the vector dot product of two things by the norm of both, right? And the dissimilarity is calculated by 1 minus this value, right? So in this we can get like the mentality or the feelings which which students have for each teacher, right? So the vectors can be calculated through tokenization or embeddings, in which you can just embed these words and then take out and just dot product it, and you will get somehow the dissimilarities for it, right? So these were the um, answers for the different sub questions for question number 5, and in the next video we'll see the question number 6. Thank you.